Alright, so in this video I'm gonna do that same problem again. So this is from page 858, chapter 13 test. And we're looking at problem number 8, which is the airplane problem. So in the last video I made one where I did that problem using vectors. I'm gonna do that same exact problem using the law of cosines and law of sines instead. So you can see both methods. Again, for this problem, I think the way it's positioned in the test is intended to be a law of cosines problem because of how the tests usually go in the order of the sections. On your actual test that I give you, it doesn't matter which method you use. You can use anything that you've learned about in this unit. So you've learned vectors and you've learned the law of cosines. You can do either one. I personally feel the vector method is much easier for this problem, and you can look at the video I made about that. But I'm going to do this with the law of cosine, so you can look at it that way as well, and you can see how to do it both ways. So in this one, I'm going to draw the same diagram. I have a point A, and I'm going to exaggerate some of the features on my diagram on this just to make it easier for me to do some of the stuff I need to do for the law of cosines. So I'm going to not draw this to scale at all. I'm going to go quite dramatically changing on these angles. Obviously, the angles are not this dramatic in the change, but I'm just going to draw it that way. So those are my 3 points A, B, and C. I know this is 370, I know this is 240, and now I need to find this length and this angle. So angle A and side length B. What I'm going to do now is I need to figure out some angles inside this triangle. Right now I have two sides. It would help if I figure out what angle B is, because that will then I can use the law of cosines. I have two sides in the included angle, and I can get its opposite side. So let's try breaking up this diagram a little bit. So I'm going to draw a parallel of vertical and horizontal line from both of these points. So I know this angle is 24 degrees. I know this angle is 37 degrees, again, not to scale, which means at least this section of angle B is 53 degrees, obviously not to scale. This bit of angle B is 90 degrees, so I know it's at least 143 degrees for angle B, and now I need to figure out what this angle is. But if I look at my diagram, I kind of tilt my head a little bit. I have this vertical line and this vertical line. Both of those are parallel, and you have a diagonal going through them. That's a transversal. And so if I have this angle, that's 24 degrees, then this angle also has to be 24 degrees. They're alternate interior angles, which means they are congruent. They have the same angle measure. So that means angle B is the 53 degrees plus the 90 degrees plus the 24 degrees. So this is the bit that I find kind of annoying to do with the law of cosines, and which is why I would rather do these problems using vectors, because sometimes I don't really see the geometry of this as quickly to figure out my angle measures. So this is just the first step you'd have to take. Again, in vectors you do also have to find angles, but those standard position angles, and they tend to be easier to find. But these problems are possible to solve in multiple ways. So angle B is 167 degrees. Now I can use that information to use the law of cosines to solve for this side. So I know this side, AC squared, is the same as AB squared plus BC squared minus 2AB BC cosine angle B. So that's 370 squared plus 240 squared minus 2 times 370 times 240 cosine 167 degrees. So if I type all of that into my calculator, I'll do 370 squared plus 240 squared minus 2 times 370 times 240 times cosine 167. And that gives me 36754.8.1235. And again, I'm not rounding intermediately. I'm going to keep all those digits from my calculator, just take the square root of it. And when I square root it, I'll get 606 5.257 miles for AC, which is the same answer I got for the magnitude of the vector AC when I solved this problem using vectors. The second thing I need to know is what angle A is, because that can tell me what the bearing. So for the bearing, I'd have to do 24 plus whatever angle A is. So now I know this is 606.257. I know angle B is 167, which means I can do the law of sines on it. So sine of 167 degrees divided by 606.257 equals the sine of A divided by 240. So the sine of A is 240 sine 167 divided by 606.257, and so that's 240 sine 167 divided by 606. You get 0.089051691. Again, I'm not rounding in between. I wouldn't even put this, right? I'm just gonna take what the calculator gives me and then do the inverse sine on it. So I take inverse sine of this stuff, and I'll get 5.109 degrees. So my actual bearing, so angle A is 5 degrees. My bearing is always measured from the north, so I start off with my 24 degrees, and I add in the 5.109 degrees, and I'll get 29.109 degrees as my bearing. So this is the way to solve that same problem. It's question number 8 in the chapter test, using the law of cosines and the law of sines instead of vectors.